Hi guys, I'm going to show you how to answer any design and technology explain question. I'll be focusing on the Edexcel exam board. I'll go through a 4-mark question and a 6-mark question and give you tips you can replicate with any similar question. By the way, I did GCSE Edexcel DT 2 years ago and got a grade 9. So, figure 11 shows a template that is used when marking out the base of the tabletop game. Let's have a look at what this game is. It looks like this. So this is the whole sort of picture of the game. That shape there. Does it say what material it is? No, it doesn't. Okay. Explain 2 advantages of using a template to mark out the game base when manufacturing in large quantities. So, 4-mark question. You're giving 2 advantages. You have to give 2 advantages. So basically 2 sets of 2 marks. 2 marks for the first advantage, 2 marks for your second advantage. Basically, the advantage of a template when working with large quantities. That's the main sort of bit of the question. So let's think about this logically for a second. You have this shape, let's say it's like made from MDF, for example. You get a massive sheet of MDF. You need to cut out a bunch of these little shapes here, right? What is the best way of doing that? So the reason about marking out, if you were to sit there with a pencil and a ruler and draw each shape individually out, that would take a long time. So using a template, one advantage of using a template is it saves time. You can make the template once, make the shape once, and then just sort of draw out, like again, the sort of copying from the same shape. Or you can, like router, for example, you can attach the template piece. If you have an already cut out template, you can attach that onto your sheet and then just router around it without having to get a pencil and sort of draw again from scratch each time. So one example I'm going to say, one advantage I'm going to say is it saves time. So template can be reused and can be drawn around and reused many times. That's my point, which means that, so whenever it's a 2-mark question, you have to give a point and one explanation. So the template can be drawn around and reused many times, which means that it saves production time. Simple as that. Or it takes, even just say, which means that it takes less time. And then to mark out all of the different quantities of bases. So you have a point, you say which means that is your connective into your reason, your second, like your explanation basically. So let's get rid of that. Let's do this one more time with our second advantage. So one advantage is saves time. Second advantage, again, think of this example here. If you're sitting there with a ruler and pencil, drawing each one from scratch, each from scratch, the chance of you making a mistake is quite high. Yeah, or getting it slightly off, getting from myself like 10 millimeters, 9.6 millimeters or something. So another advantage of using a template, using the same identical piece again and again and again to mark out all the different pieces is accuracy, right? So each piece will be identical to the template, which means that there will be, for example, no wastage in faulty components or faulty components. That would be a second reason for this. So again, as I said, each piece is going to be the same as the template. You're just copying directly from the template, which means that there'll be no wastage in caused in having 40 components that you have to then chuck away because it doesn't fit something. So that is that's how to answer this sort of question. 2 sets of 2 marks and you have some sort of connective, which means that you give a point, you give an explanation. You do not need to write like 3-4 sentences. One short sentence like this is enough for each one. Okay, let's now have a look. So that was the 2020 paper. Let's have a look at the 2022 paper and find probably a 6-mark explanation question and follow the same steps for that one as well. So I'm just looking for drawing question, 4-mark question there. Okay, here is a 6-mark explanation question. So giving 2 reasons, this time each one is worth 3 marks. Each one of these is now going to be 3 marks instead of just 2. Let me change the color on this. Okay, so the main body of the flower vase could be fabricated from separate pieces of ash rather than from a single piece. Explain 2 reasons for fabricating the main body of the flower vase from different separate pieces of ash rather than manufacturing it from a single piece. So let's actually have a look at the question, because this is part D of the question. That's the calculation question. Okay, so here's the actual question itself. So here's the vase we're talking about, made from ash. So the main body is cut out from a single piece of ash, and the 2 side pieces are bent outwards by placing in the top part to form the curves. So we have one piece, it all looks like that's one piece, and that's one piece as well. Yeah, main body is one piece, and then top part is the separate piece. Okay. Let's actually just do this entire question. I'm going to do the entire question. So part A is just a 1-mark question. State the type of force the top part is subjected to from the 2 side pieces of the main body. Let's think what's going to happen here. Let me switch color one more time. So we have this top part in the middle here, and then these 2 pieces are squeezing, aren't they? They're almost like going to be trying to straighten up. So originally the 2 pieces were like straight. They've been bent outwards. They're going to want to move back in. So they're going to compress, they're going to squeeze the middle piece there. So we can say the type of force is called compressive force. Something's squeezing, something's being compressed. Compressive force. That would be that one there, compressive force. Okay. Here we can do our same sort of skills from last question we did. Explain 2 working properties of ash that make it an ideal material for the flower vase. So ash, we know, is a hardwood. Let's have a think about the working properties of ash. So, first of all, so all of this is made from ash, so it's been cut in some way, it's been, on the bandsaw or something. We can see here that it's been bent. How has this ash been bent? It must have some level of like flexibility. Well, it's been laminated, so it's been steam bent actually. So it's been soaked in water and slowly bent. But that means ash must have some sort of flexibility. If you have, for example, a piece of steel, you wear a piece of steel, it's not gonna, be able to bend like this. The ash has some sort of flexibility, to be able to bend in that shape. And then also we can think, linking to part A, these 2 curved pieces are squishing in the middle piece. This middle piece is resisting, right? It's pushing back, it's trying to stop being squashed. So that means it must have good compressive strength. It's being compressed, but it's withstanding that, so it must have good compressive strength. So it's basically like not being squished, it's trying to resist that. So those are the 2 points, and then we can think about the explanation. So first point, ash, we can say just ash is flexible, or ash is able to be bent. Let's say ash is flexible, which means that it can be steam bent, or just bent. Let's assume it is just bent, which means that it can be bent to form the 2 side pieces. There. So that's 1 point there, 1 point, and then explanation using which means that to connect both of them. Connect the sort of the first half, the sentence, and the second half. Second point, and we said that ash has good compressive strength. So ash has good compressive strength. And again, which means that the top part will not be compressed or shrink from the pressure. Okay. So as we said, yeah, the pressure from coming this way is not gonna basically make it shrink, make it just like break in half or something. And that is how I'll answer this 4-mark question here, explaining 2 working properties. Let's do this maths question actually. So calculate the volume of waste material So at GCSE level, all of these maths questions are going to be like foundation level maths. That your GCSE, like compared to your GCSE maths, foundation level. So calculate the volume of waste material produced when making the main body. We're using pi and then cm cubed. Okay, volume of waste when making the main body. Figure 11 shows the main body. Figure 11 is all of this. So it's saying it's 20 millimeters thick, 20 millimeters thick, and then 100 by, so this here is going to be 20. Is it going to be 20? No. There's no dimensions up there. Okay. 115. What's this distance here going to be? Do we need to know this distance? No, we don't. Okay, actually, yeah, we can just focus on just the waste material itself instead of like minusing it from the whole thing. So waste material, we have, if we expand this for a second and think about it being 3D, that's going to go the down. So think of it being 3D. This piece here, we have basically a massive cuboid. So this drawing here is quite hard. Basically a massive cuboid in the middle here. And then we also have this almost semicircular piece here, which is going to look like that. So we need to find the volume waste produced. Okay, so let's get a calculator out and start doing some calculations. So first of all, this cube here, or this cuboid, has a height of 100. What's that called? Like the width of it is, so this radius here, you have to be really careful about what this means here. This radius is 15. That is 15 there. So the whole thing is going to be 30. So 100 times 30 all in millimeters. Actually, I would convert first into centimeters. I think it's easier doing it this way. So we know that's 10 centimeters times 3 centimeters, because we have to answer in centimeters cubed anyway. So all in cm, 10 times 3 times the width, which we know is 2, or like the depth or whatever you want to call it, because here it says 20, so it's going to be 10 times 3 times 2, which in my head is just 60. So that is going to be 60 centimeters cubed here. If I write that here, 60 centimeters cubed is going to be that whole shape. And then we can think about this semicircular bit. So area of a circle, actually, give me a second. Let's make this a bit thinner. So area of a circle is pi r squared. Does it tell you that in the question? No, it doesn't. So area of a circle, pi r squared. We want a half that because it's just that one semicircle. So we can do a half, or just 0.5 pi. So 0.5 times pi times r squared. R is 1.5 in centimeters squared, which we can just do as 1.5 times 1.5. That's what squared means. This is going to be the surface area, and that in my calculator gives 3.5, let's say 3.534, leave some decimal places in there, centimeters squared. Now to get it cubed, we need to find the depth. We know the depth is 20, or 2 centimeters, so 3.534 times 2 equals 7.07 to 2 decimal places there. So now we can basically add up both of these numbers here. We can add up our 60 and our 7.07 to give us in total 67.06, and they want it in nearest whole cm, so 67 centimeters cubed. Okay, and that is quite a good 5-mark question actually. Yeah. So if you, I guess if you know maths, whether doing foundation or higher tier maths, I think around 25% of your entire GCSE paper, DT paper, is going to be made of maths questions, drawing questions. So make sure you can do these skills. So that's that. Okay, let's actually go into the explanation question. So explain 2 reasons for fabricating the main body of the flower vase from separate pieces of ash rather than manufacturing it from a single piece. So this word fabricating means basically sticking 2 things together. Instead of having one big piece and carving it from that, carving is like, oh, one massive piece. Fabricating two separate smaller pieces joined together to make this whole vase. So, explain 2 reasons. So let's think of a point. What can our first point be? So we need a point, evidence, and then the third mark comes from linking it back to the actual question, linking it back to the vase. So, less waste. Fabrication, I cannot spell. Fabrication results in less waste, which means that fabrication results in less waste. We can say, okay, so that's going to be our point. Fabrication results in less waste, which means the vase or the manufacturing process will cost less material. Therefore, so we've had our point, our explanation, which means the manufacturing process will cost less materials, will be cheaper. Therefore, the saved cost can be passed on to the consumer. So we have our point, we have, okay, it affects the manufacturing process, which then will affect the consumer and make it cheaper for the consumer. One other reason, also less, we've talked about wastage. We can think about, it can be fabricated for a bunch of smaller pieces. So the main body can be fabricated just gluing things together, attaching things together. The main body can be fabricated from smaller pieces of timber, pieces of ash, which means that scrap pieces can be used from another scrap pieces can be used from elsewhere. Therefore, less raw material has to be bought. So which means that, and therefore, I would always write it in 3 separate lines if I make it really clear. So you have your first point, second, so point, explanation, and some sort of basically 2 explanations. So the main body can be fabricated from smaller pieces of ash, which means that scrap pieces can be used from elsewhere. Therefore, less new raw material has to be bought. And that is how I would answer every type of explanation question. If it's 2 marks, point, 1 explanation. If it's 3 marks, point, explanation, and linking back in some way to the context of the question or like the manufacturer, the consumer. Make it super clear to the examiner by using the connectives which means that and therefore. And then you can also sort of write your answer in 3 separate lines or 2 separate lines to make it really clear like I've done here.